said earlier that statistics is about collecting, classifying, and using numerical data. Now, sometimes we want to know how the data is spread. The standard deviation is the most efficient way of measuring the spread or dispersion of a data. It is based on the mean and shows how widely the data is spread about the mean value. Now, the larger the size, the more widely the data is spread. The standard deviation can be used to compare two or more sets of data. And the standard deviation is the square root of the variance. Now, there's a formula we use for working standard deviation. It is given by S is equal to the square root of the sum or sigma x minus x bar squared, all divided by n. Now, we'll explain this formula as we go on. To find the standard deviation of an ungrouped data, you have to first find the mean of the data. Then you subtract the mean from each of the data and square the difference. After that, you add the squares of the differences. Then you divide the results by the total number of observations you have in your data. Finally, you have to take the square root of the results. Now, let's look at an example of how to find the standard deviation of a set of numbers. Example 1 says, find the standard deviation of the set of numbers 11, 12, 13, 14, and 15. Now, let's look at the solution. We said the first thing is find the mean. And the mean is given by x bar. So we say our x bar is equal to sigma x divided by n. We have used this formula before. So the sum of all the x's, the sum of all your values, and that gives us 11 plus 12 plus 13 plus 14 plus 15, all divided by 5, because we have 5 different numbers. Now, when we work that, we will get 65 divided by 5, and the answer is 13. Now, we are going to use that mean to continue our working. So what we are going to do is to subtract the mean from each of the values and square the results. Then we find the sum of the squares of the differences. And then we divide by the total number of observations or values. So that gives us 11 minus 13 squared, 12 minus 13 squared, 13 minus 13 squared, 14 minus 13 squared, 15 minus 13 squared, all divided by 5. Then we take the square root. And again, we get negative 2 squared plus negative 1 squared plus 0 squared plus 1 squared plus 2 squared, all divided by 5. That becomes 4 plus 1 plus 0 plus 1 plus 4 divided by 5 under the square root sign. When we simplify further, what do we get? We get 10 divided by 5 under your square root sign. So that gives us the square root of 2. And your answer finally is 1.41. Now, the same calculation can be done in a table form. And we can put these values in the form of a table. So in the table, we will have a number of columns. First, we'll have our X. That stands for the numbers in our data. So our numbers are 11, 12, 13, all the way to 15. In the next column, we'll have X minus X bar. That means we'll take each value, and subtract the mean. And write down the answer. So we have 11 minus 13, which gives us negative 2. 12 minus 13, which gives us negative 1. 13 minus 13, which is 0. 14 minus 13, which is 1. 15 minus 13, which is 2. Now, in the last column, we'll square the answers we got. So we have 4 for negative 2 squared, 1 for negative 1 squared, 0 for 0 squared, and so on to the end. Now, the next thing is we'll find the sum of all the x's and write it down. Then we'll find the sum of all the values that we got when we squared and put down the answer. And then finally, we put these values in our formula for the standard deviation. Now, from the table, you can see sigma x. The sigma stands for the sum. So the sum of all our x's is 65. Again, you can see sigma and then in brackets x minus x bar all squared. That is the sum of all the squares of our values, and that is equal to 10. Remember, our mean was 13. So now we are going to put these values in the formula for the standard deviation. Now, the formula of the standard deviation says the standard deviation S is equal to the square root of the sum or sigma x minus x bar squared all over n. So substituting our answers, we'll get the square root of 10 divided by 5. And that gives us the square root of 2, which is equal to 1.41. So as you can see, you can either use the table or you use the values without the table, but you get the same answer. Again, let's look at the standard deviation from an ungrouped frequency distribution table. Now here, the standard deviation is given by S is equal to, S stands for the standard deviation, and S is given by the square root of sigma f times x minus x bar all squared divided by n. So we are going to use this formula as well to work a few examples. So example 2 says, find the standard deviation of the frequency distribution given in the table. And in our table, we have ages in years, and we have the frequencies. We have the ages from 6 to 11, and we have the frequencies from 4 going down. I'm sure you can see them. Now, let's look at the solution. So the first thing we do is to form a table. And in the table, we are going to have 5 columns. We will form the first 3 columns, use it to find the mean, and then we'll use the mean to complete the last 2 columns in our table. So from our table, you can see the ages 6, 7, 8, 9, 10, and 11. Then we have our frequencies 4, 6, 10, 11, 8, and 1. Now, in the next column, we have the frequency times x, or fx. We will multiply the values by their frequencies. So we have 4 times 6 to give us 24. Then we have 7, which is the age, times the frequency 6 to give us 42. We have 8 for the age, times the frequency 10 to give us 80, and so on to the end. At the end of that column, you have to find the sum. Sigma fx means find the sum, the total. So we have the total there to be 336. Now we'll use that to work the mean for the data. So after the first three columns, we'll first find our mean. The formula for the mean is sigma fx divided by sigma f. Now our sigma fx from the table is 336. Sigma f is 40. So when we divide, we'll get our mean to be 8.4. Now we go back to the table, and in the next column, we are going to have x minus x bar all squared. That means we are going to subtract the mean from each of these numbers or ages. So we go back to the table and we complete the table under the x minus x bar squared. So for the first one, we are going to have 6 minus the mean, which is 8.4. Then we square the answer and we get 5.76. For the next one, the age is 7. Our mean is 8.4. So 7 minus 8.4 squared, and we get 1.96. Again, we take the age 8, subtract the mean, which is 8.4, and square, and we get 0.16. And we do that for all the others. In the next column, we are going to multiply these answers we got by the frequencies. So again, you take your time. Take each of the answers in the fourth column and multiply by the frequency. So again, we are going to have 4 times 5.76, and that gives us 23.04. Then we have 6 times 1.96. That gives us 11.76. And then we have 10 times 0.16, which gives us 1.60. And so on to the end. Then in the final column, we are going to find the sum. You see that you have sigma f times x minus x bar all squared. So that means find the total. And the total there is 67.60. Now, what do we do after this? So we are going to substitute the values into our formula. And then we work it out and take the square root of the answer. And that gives us the standard deviation. So let's go. So we have the square root of 67.60 divided by 40. And that gives us the square root of 1.69. And our final answer is 1.3. And so the standard deviation for that distribution is 1.3. Now there's another formula we can use also for finding the standard deviation. But in that case, you will not have to work your mean first. You just put your values in the table and you can get your standard deviation without working out the mean first. Now we have all these formulae. Don't let them frighten you. Just use them as you study, and before you are aware, it stays in your mind and you can just work with them. So let's look at the next formula for standard deviation. Now this formula says S, or the standard deviation, is equal to the square root of sigma f times x squared divided by sigma f minus, into brackets, sigma fx divided by sigma f all squared. I'm sure you can see that the second bracket under the square root sign is standing for the mean. So to find the standard deviation, again, we can form a table, and then we pick the values from the table, put into that formula and work it to get our standard deviation. So we have the next table. And in the table, you can see the age, the frequency, fx, which means we are multiplying the frequency by the age. Then we have fx squared, which means we are squaring the age and multiplying by the frequency. We will take our time and complete all these columns in our table very carefully. Then we'll find the sum in the various columns and put them in our formula. So from the table, the first age is 6, frequency is 4. Under fx, we have 6 times 4, which is 24. And then under fx squared, we have 144, which means we are multiplying 4 by 6 squared. The next age is 7. The frequency is 6. So we have 7 times 6 to be 42. And then we have 294 for 6 times 7 squared. In the next one, we have the age to be 8. Frequency is 10. So we have 80. And then we have 640. And as you go along, you can see 9, 11, 99, 891. And we have 10, 8, 80, and 800. Then we have 11, 1, 11, and 121. Now we have to find the sum of all the frequencies, which is sigma f. That is 40. We have to find sigma fx. That is 336. Then we have to find sigma fx squared, which is 2,890. So we take the standard deviation formula, and I'm sure you can see the formula. We are going to substitute the values in the appropriate places. So we get our standard deviation to be equal to the square root of 2,890 divided by 40, which is sigma f, minus into brackets 336 divided by 40, all squared. And we are supposed to take the square root of all this. So you work everything first, and then you take the square root. So we have a standard deviation to be equal to the square root of 1.69. And that gives us 1.3 years. Remember, when you use this method, you don't need to work the mean first. When you use the other method, you work the mean and you use the mean to complete your table and put the values in your formula. Now, whichever of the formulae you are comfortable with, you can use. We want to look at what is called the variance.